Hello and welcome to Lesson 2 in my series of videos explaining logarithms and exponentials. So this video covers content from the A-Level Year 1 Maths syllabus. So last video we explored what logarithms were, some common rules, how to use them in questions, and this very important rule up here on the screen now. But in this video we're going to be looking at some slightly more complex rules involving logarithms, and I'll be showing how to derive them. Now, we're going to do this using rules we already know about indices. Some common rules for indices I'm going to go over now, and hopefully you're all familiar with these from GCSE or from earlier in your A-level course. So the first of these rules is that x to the power of a times by x to the power of b is equal to x to the power of a plus b. And this makes sense because if you multiplied x by itself a times, so x to the a, and then multiplied that by x multiplied by itself b times, so multiplied by x to the b, you would have x multiplied by itself a plus b times, which is represented by x to the power of a plus b, as you can see on screen now. The second of these indices rules is x to the power of a divided by x to the power of b is equal to x to the power of a minus b. And this makes sense because if you multiplied x by itself a times and then divided that by x multiplied by itself b times, the x's here in the b bit would cancel the ones in the a times bit, leaving you with x multiplied by itself a minus b times, which is represented by x to the power of a minus b. And then the final indices rule is x to the power of a in brackets to the power of b is x to the power of a times by b. And this makes sense because if you multiplied x by itself a times and then multiplied that by itself b times, you would have x multiplied by itself a multiplied by b times, which is represented by x to the power of ab. So those are the three rules, and we'll try and derive some logarithm rules using these indices rules now. So say for example we had x to the a equals m and x to the b equals n. Now this means that mn, so m multiplied by n, would be x to the a multiplied by x to the b, which using our indices rule from earlier is equal to x to the power of a plus b. And then using this logarithm rule that we have at the top of the page here, we know that this will be equivalent to a plus b equals log base x of mn. But using the very first statement we had at the top of the page here, x to the a equals m and x to the b equals n, we also know using this rule that a will equal log base x of m, and b will equal log base x of n. And we can substitute this value, or this statement for a and this one for b, into this statement here, and say that log base x of m plus log base x of n will equal log base x of mn. So this is our first logarithm rule here. When you add two logarithms of the same base together, so these two logarithms here, you can write this as one logarithm of the same base, with the number inside being the product of the two original numbers. So that's our very first logarithm rule there. The second logarithm rule we're going to go over now. Say instead of multiplying m and n, you divided m by n. So we have m over n is equal to x to the a divided by x to the b. And then using our indices rule from earlier, we know that this will equal x to the power of a minus b. And then again, using this logarithm rule that we have at the top of the page here, we know that a minus b will equal log base x of m over n. And again, we already know what a and b can be written as, so we can substitute those into the statement here to say that log base x of m minus log base x of n is equal to log base x of m divided by n. So when we have when you subtract one logarithm from another when they have the same base, you can write this as one single logarithm of the same base with the number inside being one of the numbers divided by the other number. So it's pretty similar to the rule we had before, but now when you subtract, you divide, whereas before when you add, you would multiply. So that's the second logarithm rule that we've derived there. So now looking at the third rule, if we wrote m to the power of b, we would say that this is equal to x to the a in brackets to the power of b. And we know from the indices rule from earlier that this will be x to the ab. And then using our logarithm rule at the top of the page here, we know that log base x of m to the b is equal to a multiplied by b. But again, we already know that a can be written in this form, so if we substitute that into the statement here, we know that log base x of m to the power of b is equal to b multiplied by log base x to the m. So when we have a logarithm of a number to the power of another number, we can sort of bring this power down in front of the logarithm and have it multiply it instead of being a power. And if you think about this, it makes sense. If we use the example from earlier, so log base 2 of 64, we already know that this is 6. But we can actually work this out using this new power rule. We know that log base 2 of 64 can be written as log base 2 of 2 to the power of 6. And then using the power rule, we can bring this power 6 down in front of the logarithm and have it multiply it instead. And then we know that log base 2 of 2 will just be 1, because you have the same base and the number, which means that the answer to this will be 6 multiplied by 1, which is just 6. And that's the same answer that we got earlier. So it's just kind of another way of solving questions using a different method, but the logic is still the same. So another interesting rule that we can look at is the logarithm of a reciprocal. So what's another way of writing this? Well, we know that 1 over a constant is the same as the constant to the power of minus 1. So we can rewrite 1 over m as being m to the minus 1. And then using the power rule, we can bring this minus 1 down in front of the logarithm. So in fact, the logarithm of the reciprocal of a constant is the same as minus 1 times by the logarithm of the constant itself. So that's another rule that we can add to our list there. So using this list of logarithm rules, we'd now be able to answer questions like this. We want to write this statement here as one single logarithm. So we'll start by dealing with this first logarithm here, 3 log base a of x. And because we have this constant 3 multiplying the logarithm here, we can bring this constant up, so to speak, as a power using the power rule. And then because 1 over y squared can be written as y to the power of minus 2, we can use the reciprocal rule to bring the power of minus 1 in front of the second logarithm here. So this minus 7 would become plus 7. So if we apply those rules, it would give us this result. We've brought the 3 up as a power, and then we've changed the sign of that and removed the reciprocal. And then we can use the power rule again to bring this 7 up as a power. So we multiply 7 by 2 to give us the power of 14. And then because these two logarithms have the same coefficient and base, we can use the first addition rule here to write this as one single logarithm. So we write this as one logarithm with the number inside being the product of the two previous numbers inside the previous logarithms. So this is log base a of x cubed multiplied by y to the 14, and that's written as one logarithm, which is what the question asked us for. So now before we finish, there is one more rule that I want to cover, and it's known as the change of base rule. So first, let's start with this statement here. A to the m is equal to x, and then using the rule at the top of the page here, this means that log base a of x will equal m. So after this, let's take the logarithm base b of both sides of this equation here. So let's apply log base b to both sides of this equation. So we can write that log base b of a to the m is equal to log base b of x. We've applied log base b to both sides of this equation here. And then using the power rule, we can bring down this power m to the front of the logarithm. So m log base b of a is equal to log base b of x. And then we can divide both sides of this equation by log base b of a to write the m is equal to log base b of x divided by log base b of a. But at the top of the page here, we already see that m is equal to log base a of x. So we can write that log base a of x is equal to log base b of x over log base b of a. So here we've changed the base of the logarithm from a to b, so we've changed what the base is, and then written it as two logarithms with a new base divided by one another. So hence it's known as the change of base rule, because we started with base a and then wrote it as logarithms with different base. But the number we're finding the logarithm of at the top of the fraction is the original number we were finding the logarithm of, in this case x, and then the number that we're finding the logarithm of at the bottom of the fraction is the old base of the original logarithm. So hence it's known as the change of base rule. So we can add that to our list of rules there. And then there's one more special rule that we can discover using the change of base rule. So we can try and rewrite log base a of b using the change of base rule. So say we wanted to change the base from a to b instead of a using this rule, we can rewrite this logarithm as log base b of b on top, because that was the original number we were wanting to find the logarithm of, and then log base b of a on the bottom, because that was the original base. But we know that log base b of b will be 1, so this can be rewritten as 1 over log base b of a. So this tells us that any logarithm can be rewritten like this. We can switch the base and the number around and then do 1 divided by that, and these two statements will be the same. So that brings us to the end of the video. Some quite tricky proofs here, so hopefully I managed to explain them well in a manner you could understand. Let me know how well I did in the comments below. Any feedback or criticism is welcome. Next video, I'll be explaining the relevance of a special number called e and how it can be used in logarithms, so make sure to check that out. Give me any feedback or ask any questions in the comments below, and I'll see you in the next video.